Okay, since Asia Open RAN is really focusing more on the RAN aspect, the radio access network aspect, why is it that this course is even discussed to begin with? On the contrary, in fact, aren't the SDN and NFV separate technologies that are, if we're going to put at it in a bigger perspective in the telecommunications network, is not really much on the wireless access part, right? But regardless, we still offer this course, no, so that for you to have an end-to-end picture and understanding on the entirety of the mobile service network, no. To be more specific, SDN and NFV, and even OpenFlow at that, these are technologies that play in between, and without doing so, it has to also pass through the transport network, which is where SDN and NFV would be playing out respectively. Okay, so throughout the entirety of this course, this discusses really more on the transport and core aspects and how it now plays out into our wireless access network. It covers also a bit of a deep dive on the specific technologies and features on what SDN and NFV plays out in order to support um, the radio access network, right? But it primarily focuses more on the transport and core side. Having said that, no, the rest of the modules found in our course, first few modules, in fact, modules 3 and 4, it covers more on the SDN part, which is software-defined networking. I'll be also giving out a few slides on what is to be learned in this module. And finally, modules 5 to 6 is now a focus on network functions virtualization. This is where now the core domain would be coming in, no? And how virtualization also plays out in deploying the important services needed for our telecommunications network. Lastly, the last two modules were actually combining already the concepts of OpenFlow, SDN, and NFV, and give them a better, bigger picture on how it now provides other services specifically to our telecommunications network. So this is where also we would be understanding the likes of the 5G network, how is SDN and NFV being used as a paradigm in deploying our core services, no? As well as how moving forward, the network, the core network would now eventually evolve into more upcoming and technology ready generations. No? So right now, as you are already aware of, 4G is already arguably at the peak of usage in, at least here in the Philippines. And majority of services that we have right now is already running in 5G. There are already talks, in fact, of 6G coming into picture, but again, that's a different story for us to tell. No? So I'll just give you a quick skim through on what SDN is. So I'll also give out to you what is the SDN architecture, its benefits, and provide you the different SDN model types. Now, what is SDN? Some of you might not be familiar yet, but some of you might have already encountered this, especially if you are in the field of IT enterprise. So we all know that SDN is also called software-defined networking. This is actually a relatively existing technology. No, I say existing. It's because this is a way for us to separate how our network devices are laid out in our network and how packets are being processed within that said network. Right. Normally, whenever we deploy our networks, and most of the time we use our switches to pass packets around in the network itself, specifically in our local area network, we need also have an understanding on two aspects. First off, that the switch themselves are split into two logical functions. There is the control plane and the data plane. That's the first concept. And then the second concept is that majority of the traffic or packet forwarding being done by this network is being controlled by the control aspect of your network devices. No, so having said that, no, normally whenever we have a traditional network, this control plane, this is where our protocols would reside, and this is also where we do all of the necessary configurations. No? Majority of the intelligence within that given switch is within also within the control plane. Now, whenever there is a challenge in the network, meaning, for example, one of the switches go down, no, we now solely rely on the other remaining connected switches for it to form also what's called network convergence, meaning that your network is, even though there is one faulty switch, we now depend on other switches for us to continuously also provide and forward our packets as needed. Okay? So, of course, having said that, this architecture has some limitations. Now, this is where SDN would be coming in as a solution, because one or the main feature of SDN is that we are now centralizing the control plane of our network. And we do so by already assigning a specific entity, a network element, called the SDN controller, whose sole responsibility is to be the centralized means of forwarding the necessary configurations being done by the forwarding switches underneath, or the ones that are connected to it. Now, there is an advantage on having this said architecture. One of them is, in fact, so I'll be skipping a few slides here, is that it is now software driven in such a way that the control aspect is now in a single logical device. And whenever there are configurations being done, it is now just being done on that single device. Okay, so in other words, it is already set up as a centralized configuration and resource provisioning across your entire network. Now, this is a bit of a double-edged sword, frankly, because having only a single point of configuration also means that in terms of security, it is also centralized. So remember that whenever we are already dealing with a network, we also have to put into consideration the security aspect of it, and as much as possible, reduce the number of vulnerabilities that our network can experience, especially if it is connected already to the internet or to the outside. Now, this may be both a strength and a risk because you are already centralizing, or you are putting the intelligence in a single point of failure, also possible. Okay? So that's one feature. And then another feature is that everything is already software based. In fact, in an SDN environment, normally when you deploy an SDN controller, you don't necessarily have or need to have a specific hardware that functions as the SDN controller itself. In fact, you can deploy the controller to be a virtual machine, okay, or an application that is already deployed in an existing server. So it becomes software-based, contrary to how we normally deploy our network, which is hardware-based, wherein the control aspect is still embedded into our switches. Okay, so I'll be skipping here some, I'll be going back here a few slides. Now, for us to better also understand what SDN is, we also need to have a quick understanding on what does it mean when our network is SDN enabled. Now, consider now this diagram that I'm currently showing to you here. This is a typical representation on how the SDN architecture would be laid out. Normally, it consists of 3 high-level layers. You have the application layer, the control layer, and the infrastructure layer. Both or all 3 of these layers are communicating through what's now called application programming interfaces, or APIs. Now, remember what I said a while ago in the very beginning that the goal of SDN is for us to have a separation between the control plane and the user plane. And it's or this separation is best illustrated using this diagram because you'll now notice that the control plane is now represented using the control layer where the SDN controller plays. And your forwarding plane, this is now where your infrastructure layer or your forwarding switches would be residing. Now, another relevant feature for SDN is that because it is also software based, okay, software driven, it is now also possible for you to have additional features that you may want to incorporate into your network, such as the likes of having a load balancer or even a firewall already also part of your SDN controller. In fact, no, there are also some vendor providers nowadays, no, saying the likes of Ericsson, Huawei, Nokia, who offer their SDN controller solutions to also come pre-bundled with other features that can also be used in our network, such as these two that I mentioned here in the diagram. Okay, so these are just the high-level concepts on what SDN is. No? So why are we even deploying this in the first place? Now, there are several benefits on deploying an SDN network into the telecommunications network in general. So these are just four: simplified policy changes, no, network management and visibility, reduced hardware footprint and OPEX. This is in fact one of the main benefits of deploying SDN because essentially you are already removing, or it's no longer necessary for us to deploy a controller to be hardware. In fact, you can just purchase a software application that is your SDN controller, and if you have any hardware lying there already available for use, you can deploy it there. Or even better, if you know virtualization, you can even deploy SDN to be a virtual machine, no, inside your network. And finally, networking innovations. This is primarily driven to SDN being completely software driven. And we all know how flexible it is for software to be manipulated. And by that, I mean that it is now easy for us to just spin up a new application on the fly as needed. And this also pushes manufacturers and vendors to be more competitive in terms of their solutions. No? Suppose they want to have their SDN be flexible enough to just be deployed as a software, they can do so. And this can already be a purchasing edge for telecom providers in getting their solution. Okay. Now, what are some challenges being faced by SDN? So definitely, this is not a technology that is a one-size-fits-all solution, and it's also not the golden solution that it will answer already everything. It also faces its own challenges. So first is we have security. Remember what I said a while ago about the controller being the single point of failure. So that this is one of those reasons. Another one is unclear definition. Because currently right now, unclear definition and market confusion are two. Frankly, because there is really no set standard on how you can deploy SDN. In fact, there are several iterations on how you can deploy it. And this can often lead to a bit of market confusion because say you have a given vendor and this vendor offers only an SDN environment or an SDN controller that has only X features, but the telecom operator only needs Y features. So how can both be met, right? So that's one. And then finally, slow adoption and costs. SDN technology, like what I have said, has been around since 2011. And in fact, no, it's already more than a decade. No? But then adoption has still been relatively slow. No? Many enterprises cite the cost of SDN deployment to be a deterring factor. But regardless, its presence can still not be, still needs to be acknowledged because like what I have said, no, despite it being around since 2011, there are still new ways and new methods on how we can deploy SDN in a specific network. Okay, so these are some high-level use cases on how we can deploy SDN. So we have Open SDN, SDN by APIs, the overlay model, and finally the hybrid SDN. Now, these are just a few, or what I am just explaining to you here is just the tip of the iceberg on what the course would be about. There are even a bit more nuanced discussions on what SDN is as a technology. But I'll stop for here. I'll go to the next part, which is NFV, Network Functions Virtualization. And you may have also wondered, that in my discussion a while ago about SDN controllers being offered already as a purely software solution, this is made possible through the use of another technology, which is called virtualization. And virtualization in itself is also a key technology for another technology called network functions virtualization. Okay, now what is NFV this time? This is just a way for us, or this is a new approach on how we can deploy network functions in general. We utilize a technology called virtualization. So what is it? No, in fact, no, this is also this in fact would be later on discussed by my colleague Raymond when he also tackles a bit on cloud computing. But in a gist, virtualization, this is the technology that allows us to deploy virtual machines. In other words, it's possible now for us to deploy more than one system, logical system, in a single hardware set. If I were to simplify the terms there. Okay. We also use what's called commercial off-the-shelf hardware in order to deploy specialized network elements. Okay. Back then, in a typical network environment or in a telecommunications environment, specifically to the core network, whenever we want to deploy a new service into the core network itself, example, say you want to deploy a customer premise edge equipment or a CPE or even a firewall, or in the case of our 5G network, our network slicing function, or even our carrier gateways. These functions normally also come with their own dedicated hardware. And it can be a bit of a challenge for telecommunications operators that if, say, they want to deploy 4G into their network, they also have to purchase the specialized hardware intended only to run the 4G services. Okay? Now, NFV changes a bit of that approach because instead of completely relying to vendor manufacturers to have a certain service into their network and also purchase the needed hardware to deploy said service, we can instead just use commercial off-the-shelf hardware and just purchase the software needed or provided by the said vendor. In other words, there's a bit already of flexibility for operators to already deploy their network services without completely purchasing the dedicated hardware from a certain vendor. Okay? Now, NFV, it follows also similar to SDN, it follows also an architecture, albeit this is a more standardized architecture. And you'll notice here in this architecture, there are a lot of moving pieces here, But one thing that we have to consider is that virtualization here plays an important role. Okay, now the NFV architecture itself is split into several domains. You have here the infrastructure. This is where your hardware would be residing. You also have your virtual network functions. This is now where your network services are deployed. And finally, the main component of NFV is called the orchestrator, or the management, automation, and network orchestration. Okay. Oddly enough, you can actually deploy SDN alongside NFV. And I think I have a there you go. I have an illustration for this. So you may now be wondering, no, okay, we have SDN already in play, and we know that SDN, its main feature is to split the control and user plane into two separate domains. No? But how does it play out in our NFV environment? No? Now, NFV and SDN are not dependent on each other, but they do have some similarities. Okay? Majority of the devices or components in our NFV architecture, no, are again connected by an IP-based transport layer. Imagine that, suppose your resources needed to, say, deploy a virtual firewall are split across several data centers. Through the use of SDN, it is possible for us to consolidate all of these resources and make the network perceive that these resources are just found in one large logical pool. Okay? And this is now possible for us through the use of SDN. Okay, so think of SDN as sort of like the networking glue that connects or merges all of the resources together, especially if they are found in several data centers spanning several geographical lengths or distances. No? So having said that, no, so NFV supports SDN by providing the infrastructure on which the SDN software can run, and at the same time, SDN supports NFV in a way that it is responsible for doing or combining all of the network resources as one logical pool. Okay, so similar also to SDN, NFV is a very complex technology on its own, and fortunately for us in this module, no, or in this course, we would also be discussing these a bit more in depth. Okay.